Hello again. In our last video, we had just gotten to a place where we had created all of the objects that we were going to use for our game, and we were able to get to this point where we saw our player, we saw a gem, and we saw a singular baddie that exists on this screen. Apologies in advance if any of this audio is bad. I live next door to a park, and they're doing lots of construction of digging into concrete today, which is not an optimal situation, but we'll make do. So we now want to add in some aspects of this game to allow for movement and things like that sort. So the first thing that we want to think about is how to get this player piece right here to do the movement that it's going to do. And the way that we're going to deal with that is our player piece is going to move within our run graphics game. Reason being, run graphics game is the file that extends papplet. This is our graphics window, and we're going to have our player move on some types of key presses, which has to happen inside of a graphics window. So for us, it's going to be some method that exists inside of our draw. For now, we are choosing to use the idea of key pressed rather than key released. You can change that if you'd like. Go into our old graphics if you would like to change other things, but essentially what we want to do here is if key pressed, then figure out which one and move accordingly. That's what we're trying to do right now. You can choose if you'd like to use the ASDW. I know that a lot of times for gaming situations, ASDW are great keys to use. Sometimes they're bigger than the arrow keys on your keyboard. For right now, I'm going to go ahead and use the arrow keys because that takes one extra step. So I want to remind you about that one extra step if we need it. So if we're going to do that, the first thing we need to do is we need to have a check for key pressed, which is already a built-in thing. And we used to say equal equals true, but we know that key pressed is a Boolean itself, so we're asking if key pressed is true by just saying if key pressed in this way. So if the key is pressed, the next thing that we'll need to know, if we're dealing with the arrow keys, from here, if we wanted to do things with a letter key, we would just say, well, what is the key equal to? And continue in that sense. Is the key equal to B or whatever our letter is that we're trying to deal with? In this case, we have one extra step. We need to know if the key that got pressed is a coded key, and coded is a special word in all caps in that way. If the key is coded, and then from there, we're gonna have our four checks. So we're gonna have up, we'll deal with down, we'll deal with left, and right in this case. So then we've got four cases to check. So then we wanna know if the key code that they found, so key code now, because we've decided it is a coded key. So is that key code up? And again, up is just a built-in keyword with the all caps there. If you notice as I typed that, you could see that, let's do it again for down. Key code equal equals, and as I start to type down, it has a numerical value that it's equal to, that's built in, oops, down, not dodge. Numerical value that it's equal to, that's built in similarly to how we have colors and things in that sense. It's a built-in number value. So if the key code is down, which then is 40, meaning you're pressing that down arrow. Same thing for left and right, and all of these, it's just the direction in capital letters. And then finally, right. Key code is right. Great. Okay, so now we have those four cases considered, and now we have to think about, well, what makes sense and what is it that we're doing in this situation? If the key code is up, what we would want to do is we want to change the up and down direction, meaning we're trying to change that player's Y value. So we're going to change that player's Y value. So player1.y to change its Y value is now going to be added. If you wanted to leave it really simple, we could just say plus plus here, and then it'll, you know, grow or shrink in the way we want it to. However, we need to think about what's going on. Plus plus minus minus in that way. We also could think about adding in a variable of speed in this moment, or having it be a set value that the player moves at a speed of 2 or whatever it might be. For right now, for me, what I'm going to say is that I'm going to use, well, I'm going to hard code it in, but I'm going to add in a value of 2. So that way the player, for right now, forever and always, has a speed of 2 when it moves up. And now I really want us to think about, in terms of the graphics window, what's going on when we say up and down. Thinking about that if we have this window here, these are going to be a problem for me. If we have our graphics window, at our top left corner is where we've got 0, 0, and then as we go down on the screen, our Y values increase. So if I'm trying to move up, what I actually need to be doing is subtracting, which means that if I'm then trying to move down on the screen, I need to be adding p1.y plus that 2. And that'll then take care of our Y direction movement. The next thing we need to think about is our X direction movement. So if I want to move to the left, well, p1.x, 0, 0's on this side, 600's on that side. So our X direction does move in the way a number line moves. So if we want to move to the left, we're going to subtract that 2. And if we want to move to the right, we're going to add that 2. Oops. All right, so let's try it with those 4 in place. Go ahead and run this. Make sure that you can get it so that when you press those keys, your player now moves. And now, if you notice, in this moment, I'm running over all of my other pieces. I'm in front of those pieces, but I'm behind that piece based on the order in which these things were created. But right now, I'm able to totally run over both the gem and the baddie and nothing else happens because right now I haven't dealt with any of the collision detection. So that will be our next video. But we want to make sure that we're to this place right now where all of our pieces is moving in all of this way. Now right now, the other thing that I haven't considered is that I can totally run off the screen. I have no boundaries in any way there. So right now there is absolutely no walls or barriers and I can run around, move up, and then I'm going to come back in a totally different position. And if that's how you want your game to run, that is fine and valid. However, I think that that could lead to some easy cheats to avoid those baddies if they're off the screen, or some really, really frustrating scenarios if there's baddies off the screen and your player runs off the screen and you're not able to figure it out. What's going on. So the last thing that we want to add in here is some kind of check to have some kind of boundary detection. You have multiple ways of wanting to deal with this. We can simply do it outside and figure out if our p1.x is bigger than our x value or less than the possible x value, then we should just set it equal. The other thing that we can think about is inside of this button to go up, down, left, and right, inside of that check, maybe let's prevent ourselves from actually going up if we are outside of that range. So then what I would want to do here is have just another check. So if I'm trying to move up, that means I'm subtracting in my y values. So if I ever get to a place where p1.y is, well, less than or equal to 0, then I wouldn't want to do anything. So I guess what I really want to know is if p1.y is greater than 0, then go ahead and you can say do that up thing. And I guess what I really mean is greater than or equal to 0, well, no, because we do it from the top. So what I really mean is 0 there. So if it's bigger than 0, you can go ahead and say go up, because it'll be subtracting. If it's not, then we want to do nothing. So we'll be pressing that arrow key. If our p1.y somehow gets to be equal to 0, then we should stop. If it gets to be even smaller than 0, again, we're not going to allow ourselves to go up anymore. Similarly, if we're trying to go down, we want to know if the bottom of our rectangle is hitting that bottom wall. And so in this case, what we want to know is if our p1.y is within that bound of 600. But I don't just mean p1.y, because remember that talks about the top left corner of the rectangle. What I mean here is p1.y plus whatever our p1.size is to give me the bottom of that rectangle. And if that's the case, that means we are within the bounds on the bottom, so we should move to down in that case. For the leftmost, again, we want to know if we're within frame on that left edge, so we want to know if our x value is greater than 0 in this case. And then finally, for our right edge, we want to see if we're within on the right bound, so again, we want to know if our x value is less than that 600, and I'm using 600. It's built in from here because I'm dealing with a width and height of 600. If you want to know that possibly you'll be changing that screen, you can change these to the keyword height here and width here. Those are built in to talk about the bottom wall and that rightmost wall. But again, my P1.x talks about that top left corner of the rectangle, which means that I need to then, again, add on that size. P1.size. Oops, and I think I pressed that one backwards. We want to add on that size, thinking about in the Y direction as well. Okay. There we go. Oh, I did my curly braces here to have all of these checks. All right, let's check it one last time. Here's what we've got. My player can run all around. Again, totally able to run over the gems, but for right now, it hit that top wall and it stopped. It hit that left wall and it stopped. Let's zoom over to the right wall now. Hit that right wall and it stopped. And here we go. Let's go to the bottom and see what we got. Hit that bottom wall and stop. So now we've got boundaries for just our player. I've got no boundaries for gems or for baddies at this moment, but considering they aren't moving, we will deal with that logic later on. The next thing we want to do in our next video is going to deal with collision, so that way we know when that player is in fact running over that gem. And that'll be where we pick up on the next one.